All right, this is a pretty detailed problem, so less likely to be on the AP exam, but it's a real problem. It's a real world problem. So I want to go over it anyway. So we have an oil pump out here, and they're going to pump the oil from the oil well to the shore. And so it should make sense to everybody that it probably costs more to put a pipe underwater than it does above ground. It probably needs to be stronger. It has to resist corrosion. It's going to be harder to repair. So the costs involved in that are going to be greater. So the question is, and we're trying to get the oil from this oil well down to this, what do they call that? It doesn't say why, but they want to get the oil down here. So where should you build that? Now you could do it directly there. That would be the least amount of pipe, but it's going to be more expensive because it would all be underwater, and that part is twice as much money. Okay? So it's possible that the cheapest way may be to just build it straight across here, and the water as little as possible, and then straight down here. So there are some possibilities. So the question is, how far down from A? So I'm going to call that X. Okay? So that's going to be X, and now we can do a little Pythagorean theorem up here. A squared plus B squared equals C squared. So we have A squared plus B squared equals C squared, and we could take the square root of both sides. So this is going to be the square root of X squared plus 25. And one more thing we could look at is this remaining part right here. So this is similar to the light post question. I hope everybody can figure out what that should be. It's a very similar setup. That's going to be 8 minus x. I was going to say you could pause the video and sketch that out yourself, but okay. So now we need an equation for the cost of this. So the cost is going to be equal to, I'm going to do this cost in millions. So I'm going to do 1,000,000 times, that would be the part that's underwater. So I guess I could still use red for that. Whatever. So that's going to be the square root of x squared plus 25. Then we're going to have plus 500,000 for this segment right here. So that's going to be 8 minus x. Okay? So that's our cost of the pipeline. Now, our next step, so draw a picture, label everything, then come up with an equation. Then take the derivative of the equation. That's the calculus part. So we're going to take the derivative of that. So that was to the 1/2. The 1 doesn't matter. This is the 1/2 power. So bring 1/2 down. X squared plus 25 to the negative 1/2 times 2x, chain rule, 2x. Try to pause that when you can. So here we're going to have 4. The derivative of 4 is 0, minus 1/2 x, so that's just going to be minus 1/2. Okay? So this 2 will cancel out with that 2. And if we set this equal to 0, I don't want to rewrite all that out, so set this equal to 0. So what we want to do there is add this 1/2 to the other side. So we're going to have 1/2 equals, and this, we have an x here, so that's going to be x over, that's a negative exponent, so we're going to drop that down. So that's going to be the square root of x squared plus 25. Okay? So now we need to work on this. So if we cross multiply here, that's going to be root x squared plus 25 equals 2x. So we will square both sides. That's going to leave us with x squared plus 25 equals 4x squared. So if we subtract x squared from both sides, that's going to be 3x squared. I flip the whole thing over, divided by 3, and then square root. So x is going to be 5 over root 3. Now technically it would be plus or minus 5 over root 3, but it doesn't make sense for x to be a negative in that problem, so we'll just not worry. I guess we could put it plus or minus, and then we'll scribble it out. We're not going to use that. It doesn't make sense. Okay, so now we can look at our sign chart here, and that's going to be 5 over root 3, and we can look at our values here, maybe, somewhat, back when this was minus a half over here. So that's more than 1, so I can use 1. So if I plug 1 in here, I'm going to get 1 over root 26, which is a little bit more than 5, so 1 over a little bit more than 5 minus 1/2, if we move that back over there. So that's going to be negative. 1/5 minus 1/2, that's going to be negative. And then if we plug in, I don't know if you want to plug in, what would be a good number to plug in? 9? No, not 9. Trying to think of something that's going to work well here. Plus, let's do 10. So 10, and then this is 125, which is a little bit more than 11. So I have 10 over 11 minus 1/2. So that's going to be positive. Okay, so we have a relative minimum at x equals 5 over root 3 because c prime of x changes from negative to positive. Okay. Now we go to our last step here, and we kind of do our candidate table. So we have x. So x could be 0. We could make it straight across, or x could be 5 over root 3, or x could be 8. We could do it all the way down to where it needs to be. So if we look at the cost, when we plug 0 in here, so if we plug 0 in for x, then this would be 5, so that would be 5 million, plus, and if we plug 0, or what did I say? 0 for x. So then this would be 8, or no, 0 here, so that would be 4. So 5 million plus 4 million, that would be $9 million if we built it that way. Now if we build it all the way underwater, that would be 8. 8 minus 8 is 0. That part would be gone. This would be the square root of 89. And the square root of 89 would be 9 point something million. So that would cost more. So that would cost more than that. Now, if you plug in 5 over root 3 into both of those, then you're going to get 8 point something million. So the pipeline should be built 5 over root 3 kilometers from A to B. From A toward B. All right. So at this point, I imagine some of your eyes have glazed over and you're like, man, this is horrible, and it's not that big of a deal. Like they're not going to be 5 of these on the AP exam. There's not going to be any of those probably. If there's an optimization question, it'll be a little more straightforward. Like let's look at number 5. So I think I have one on a test like this, that's why it's highlighted. So let's see if we can figure out what to do here. So you want to build a fence around your house like this. You can afford 250 feet of fencing right now. What values of x and y will maximize the area? Let's just say you own all this property around here. So the length of the fencing. So we need to come up with some variables here. Now there's 2 main ways to do that. I'm going to call this x. So if that's x, then you need to think, what is this? Well, that's going to be x minus 50. Okay, and I'm going to call this y, Now hopefully everybody can fill in this other side here. That means this is going to be y minus 40. So now what's the length of our fence? Well, we've got 2x, and we've got 2y, and we've got minus 90. Okay, so now we have an equation for our fence. All right, so our going back to our question, we want to maximize the area. So that's going to be our red equation. Okay, so I'm not there yet. But what can I do with this? I have some more information about this. That's 250. So I can plug in 250 for that. And I can simplify this equation a bit. So if I add 90 to both sides, that would be 340. And then we can take half of that. So that's going to be 170 equals x plus y. Now, the equation we want to maximize is the area that we have in our yard here. Now, that may look a little tricky, but it's not really that bad. So the area of the yard is going to be x times y, but if we do x times y, that includes the house, and that's not part of the yard. So the easiest way to handle that would just be to subtract the house out. So that's going to be minus 2,000. Okay? Now, our next step is to rewrite this equation in terms of one variable. So I'm going to go with x. So I'm going to write my area in terms of x. Now to do that, I need to make an adjustment up here. I need to solve for y. So y is going to be 170 minus x. So that's where I'm going to go here, and then that's going to go in here. Okay? So that's going to be x times 170 minus x minus 2,000. So if we distribute that, that's going to be negative x squared plus 170x minus 2,000. Okay? So, set up the equation, come up with the equation you want to maximize, substitute into that so it's only one variable, and then take the derivative. So if we take the derivative of that, we're going to get negative 2x plus 170. Alright? Now, if we set that equal to 0 and factor out a negative 2, don't get rid of it all the way. Sometimes that causes a problem, so let's just leave it there. So our number that we're looking at here is 85. And again, I didn't really talk about the domain and the range. So if we do a test point here, we plug in 80, that's going to be a negative, so a negative times a negative is a positive. If we plug in 90, it's going to be a negative times a positive, that's negative. Okay, so we have a relative maximum at x equals 85 feet because a prime of x changes from positive to negative. Because, alright, and if you plug that in, it says what values for x and y. So if you plug that back in for y, it turns out to be 85 feet by, 85 feet. Okay? This is something. All right. Let's continue here. So, maybe I will break this into 3 parts and make this last part optional, or you can just forward to the end of this last video and get the if you want them in your notes. I think that's what I'm going to do. So these last two will be optional if you want them in your notes. I won't check that notebook page. Remind me.